All right, so let's try our hand at graphing a couple of sine and cosine equations, one of each. So given the equation, we want to be able to just kind of graph this thing out just by analyzing it and picking apart the pieces. So as a reminder, um, if I have an equation that's really of these forms, but say it's just kind of more generally, it's like y equals a sine bx minus c plus d. This is the generic form. And notice the way that this first equation is written, it's negative 3 plus 3 sine 1/2 of x. This negative 3 out front, this is actually d, because this could just be rewritten. To me, this is a really strange way of writing it, but some books do it. So I would have rewritten this one as 3 sine of 1/2 x minus 3. So addition is commutative. You can just swap this over. So the d is negative 3 is one thing to be aware of. The other thing to be aware of is that sometimes you might be given an equation that's of this form. So this is y equals negative cosine 2/3 times quantity x minus pi over 3. So this 2/3 corresponds to b in my generic equation, but the b has already been sort of factored out of this bx minus c. So this right here is the equivalent of, if I was to take this exact same thing, and yeah, I recognize it's sine versus cosine, it doesn't really change, at least as far as like the factoring and the transformations go. I could rewrite this as a sine, and then I'm factoring out from this bx minus c, I'm factoring out the b, pulling it out front. So a sine b times quantity x minus c over b plus d. So this second equation here is this second form where b has been factored out. The reason that I'm pointing this out is because you need to kind of be aware of how the equation is written when you're going to go through and you're going to assign your when you're going to go through and assign your A, B, C, and D. Since those are going to determine, in particular, B and C together kind of determine the phase shift. So, and the way that I wrote this out, like in my previous video and in classes, is this is what I consider to be the generic equation. For me, a better generic equation. And from this, I said, okay, make sure that, if you're looking at the phase shift is not just C, the phase shift is C over B. When you have an equation in this form where B has already been factored out, the C over B element is kind of, element's not the right word, I don't know what the word is I was looking for, but C over B is already in there. So when you have the b factored out, c over b is being given to you directly. So I'm just pointing this out because, for instance, in this second one right here, you wouldn't want to say, oh, okay, the phase shift is pi over 3 divided by 2/3. No, the phase shift is already being given to you. So if b has been factored out, the phase shift is being given to you directly. Otherwise, if b has not been factored out, you have to factor it out, or you have to do c over b to find the phase shift. All right, so let's actually get into this now. Let's see here. So a is amplitude, a in this case, and I'm going to kind of write all of these pieces out. I'm going to write out the amplitude, the phase shift, the period, the vertical shift. I'll also write out the range, just because that will be asked for, although that the range is kind of like implicit. So yeah, this is just kind of like stand on its own. So for this, I have that the amplitude is 3. So amplitude is always the absolute value of A. Amplitude is 3. Let's see, let's do the easy ones first. The vertical shift, d is -3, so it's 3 units down, or -3, however you like to think of it. Right, period is equal to 2 pi, since it's sine and cosine. Period is equal to 2 pi over, technically, the absolute value of b. So 2 pi over 1/2, which is 4 pi. So it's going to take this, take our normal sine equation and really like spread it out, widen it a bit. That's what this will do. Doubles the period. Yep. What else do I want? Right, phase shift. So phase shift, at least on this one, kind of easy. There is none. If there is no c term, then the phase shift is 0. Because essentially, the idea is that c, in this case, is 0. So yeah, the phase shift is still c over b, but 0 divided by 1/2 is just 0. So there is none. There's no phase shift. Amplitude, vertical shift, period, phase shift. What else did I say I was going to do? I think I said I was going to do range. So range, by the way, vertical shift D tells you what the midline is. Says that the midline is the line y equals 3. So just the horizontal line y equals 3. Range is given to you both by the midline and the amplitude, because the amplitude is defined as the distance from the midline to a peak or from the midline to the trough. So if the midline is 3 and then the amplitude is 3, the distance from the midline to the amplitude is a distance of 3, which means the highest, like the peak of our wave, is going to be hit a value of 6. Midline minus 3 is 0, so the trough is going to be at 0. So the range is from 0 to 6. So d minus a, specifically d minus the absolute value of a, to d plus the absolute value of a. It gives you the range. Okay. And all of this is just kind of like helpful for getting a general sense of how this will look. So the range in particular, if the range is from 0 to 6, then everything is greater than or equal to 0. So it's all going to be greater than or equal to the x-axis. So maybe I'll make my graph look like this, where most of it is kind of above the x-axis, because that's where I want to be looking. Nothing really is happening below the x-axis. All right, so that's the first thing. I guess maybe too what I can do is I can just sort of say scale this out. So there's 6, and then right in the middle is 3. Okie dokie. What else do we want to do? Okay, so since this is a sine function, remember sine, just in general, just a really quick sketch, looks something like this. Sine comes up through the origin, like that, and it bounces around. So the way that I do this is I first track what I consider to be sort of the starting place of sine, which is where it passes through the origin. And the reason that I like to do that is because this point right here, at least for sine, it's slightly different with cosine, but for sine, this point right here is directly affected by the phase shift. It won't be affected by a change of the period. That's why, for instance, like this point right here, this sort of peak up here, I don't want to sort of track that through the phase shift, because that point is going to be affected both by the change of the period and by the phase shift. So it sort of undergoes 2 transformations. This 0, it's an invariant as far as the period goes. It's only going to be affected by the phase shift. So this point, which would normally be sort of at 0, 0, on the one hand, because of the vertical shift, this point would be shifted up 3. So instead of it starting here at the origin, it would be starting here. You can think of like this horizontal line, y equals 3, you can think of it as like almost like the new x-axis that your sine wave is going to bounce around. So here's where that point would be if there was no phase shift. Oh, right. God. And there is no phase shift, so I just kind of did all of that talking for nothing. I guess the phase shift will be more important on here. So since there is no phase shift, yeah, it's going to go right through this point. All right, and then the way that I like to do this is once I have my sort of starting point, my reference point, then I just used the periodicity of the sine function and also the symmetry of sine function within its periods to mark out the other points that I could use. So if the period is 4 pi, it means that 4 pi units in either direction from this point right here, the sine curve will hit this exact same point again. So maybe I'll just scale this out. I'll say here's 2 pi, and then over here is 4 pi. So that'll give me room to get in exactly one period. So 4 pi units, since the period is 4 pi units away from this initial point, it hits that same point right there. And now I'm just kind of keeping in my head what this mother function looks like. So right now it should be the case that this is the curve is going to come up through this point right here. It's going to hit a peak, and then it's going to come down and hit a trough, and then it's going to come right back up and hit this point again. So we're essentially mapping out this curve right here in our transformation. Well, notice that on this curve, right in between these 2 points, it's like I've marked off this point and I've marked off this point. Notice that right in between, the midpoint between these 2 points, it crosses the x-axis again, or it crosses the midline again. So that's what I'm going to mark off, is that right between these 2 points, which is 0 and 4 pi, right between those, it's going to cross the midline again. So I'll put a little dot right there, just kind of a reference. Now I just need to mark off the peak and the trough that are in this period, and I can draw the whole thing out. And again, the peak and the trough occur right in the midpoint. So this peak up here, it occurs right in between these 2 spots where the curve crosses the midline. So right in the middle of those is the peak, and the peak occurs at 6. So right in between these 2 dots is going to be the peak up here at 6. And then the same idea, the trough is going to occur between these 2 points, and the trough is at 0. So now we can just kind of, as neatly as possible, try to join these curves, or join these points in a nice curve. There we go. Something like that, and that's one period. If we needed to do 2 full periods, I would literally just do the exact same thing, but on the other side. So it's going to hit this spot at -2 pi. It's going to hit this spot at -4 pi. Over here it comes down and it's going to hit a trough right here, and then it would come back up and it'll hit a peak up here. So here are 2 periods of this particular sine curve. There it is. That's what it looks like. Okay, so let's do this next one now. Cosine. Exact same procedure. The only difference is that now it's working with cosine. And something else that I'll keep in mind too is this negative out front. So the negative out front of any function flips it over the x-axis. So the normal cosine, just again for a reference, it starts up here at 1, 0, and then it comes down and does this. So this is what cosine looks like, just in its basic form. Which means that negative cosine, I'm just doing this to kind of keep this in my head as I go through these transformations. Negative cosine, everything just flips over the x-axis. So instead of starting at 0, 1, it starts at 0, -1. And then it moves up and comes, yeah. Yep, there it is, just like that. Hits a peak, comes back down. So here's the negative cosine. And since this is a negative cosine in the equation, this is kind of more so like the model that I want to have in my head. So again, we'll go through and we'll list out everything. Amplitude, well, A is 1. I guess technically A is -1, but amplitude is the absolute value of A. So the amplitude is just 1. Vertical shift, there is none. 0. If there was some constant being added to this thing, that would be the vertical shift, but there is none. So there's no vertical shift. The period is equal to 2 pi over b. And b is this 2/3. So 2 pi over 2/3 is 2 pi times 3/2, so 3 pi. Yeah. Phase shift. Remember, phase shift is c over b, but c over b is given to us right here. This pi over 3 is c over b. b has already been factored out. So the phase shift is pi over 3, and we need to determine is that to the left or to the right. Since this is a subtraction sign in here, this is a phase shift to the right. So it's kind of counterintuitive. You might think, oh, there's a minus sign in here that's negative, so it must move towards the negative side of the x-axis. No, it's the opposite of what your intuition expects. If there's a negative in here, then that means everything is being shifted to the right. So it's the phase shift pi over 3 units to the right. And right, then the range, well, there is no vertical shift, so the midline is still just the line y equals 0. Or the x-axis. The amplitude is still just 1, so it has the exact same range as just the regular cosine, which is from -1 to +1. d minus the absolute value of a plus d, or 2d plus the absolute value of a. d minus the amplitude to d plus the amplitude. Okay, so now let's graph it. We've got all the pieces that we need to graph this thing. So let's graph it. Try to make it as pretty as possible, because yeah, like a good deal of the reason that I studied math to begin with is because I think that math is really pretty. So yeah, it kind of makes me happy to make my math look as pretty as possible. Okay, yep. So now, since it's cosine, again, with sine and cosine, I consider my starting point, my sort of reference point, however you want to think about it, it's wherever the graph crosses the y-axis. So with cosine, it crosses the y-axis up here at 0, 1. We're working with negative cosine, so the negative cosine crosses the axis at, sorry, this is 0, 1. The negative cosine crosses the axis at 0, -1. So this is the point that I'm going to track through the phase shift. So the phase shift is pi over 3 units to the right. All right. I probably should have considered the period a little bit more in making this graph, but we'll see here. Maybe I can get by with it. It's okay. We'll say that maybe, gosh, yeah, I should have considered this a little bit more. I'm just going to add a little bit over here. I think it's going to make my life easier if I can just mark this thing out to 3 pi. So we'll say I want 3 pi to be right here. So I'll split this into thirds. There's maybe 2 pi, and then maybe here's pi. Okay, and this thing is undergoing a phase shift of pi over 3 units to the right. So here's pi, pi over 3 would be, oh, about right there maybe. And it's this point right here that is getting shifted over, pi over 3 units. So our graph is going to cross right here. And in particular, where the graph crosses right here, it's going to be this trough. So what I would like to do now, I'm going to add on even just a little bit more space. I didn't plan this very well. There we go, so that I can hit 3 pi plus pi over 3 over here, because that's when it's going to hit this spot again. So this spot is right here is pi over 3. The period is 3 pi. So if I add 3 pi units onto here, my graph is crossing this exact same spot again. So that might be about right here or so. Maybe right there. That's where my graph crosses it again. So now it's kind of like I've plotted this point and I've plotted this point exactly one period later. This is where I start chopping things in half to start finding like the peaks and the troughs where things are hitting midlines, whatever. So right in between these two troughs, the midpoint between them corresponds to a peak. So right in between these two, the midpoint between them is hitting the peak. Let's see, just for a little bit of accuracy, those points are pi over 3. Maybe this is more obvious than I'm making it. Right, yeah, so it's half of a period. Half of a period would be 3 pi over 2. So I just need to add on pi over 3 plus 3 pi over 2, half of a period, is 2 pi over 6 plus 9 pi over 6. Is that right? Right, I multiplied this by 3. Yeah, I multiplied that by 2. Yep, okay. When I do that, I probably come across as like a way more incompetent mathematician than I actually am. Maybe, at least to some people. Other people might see it as making me a more competent mathematician because I'm being so precise. So 11 pi over 6, this is what, pi plus 5 pi over 6, yes? Okay, so yeah, I'm just going to have to estimate that. So here's pi. 5 pi over 6 would be, well, here would be like 2 pi over 3. So 5 pi over 6 is, I don't know, right here. I could have just, I guess, actually done like the midpoint of those two, but it's fine. Like just measuring out where the midpoint was. I kind of wanted the actual point though. It's close. Yeah, it's not perfectly symmetrical because this spacing is not perfectly symmetrical. I could have used a compass if I really wanted to be kind of anal about it. And really this is probably all that I need in order to make this thing. I could like actually kind of maybe figure out what these points are where it crosses the x-axis. I don't know if it's really all that necessary. At least for me, what I'm looking for is not so much all of that precision. Yeah, I just kind of want like the general, can you sort of graph this out? Can you algebraically find some of the key pieces that you would need and then give me a rough sketch of what it looks like? Yeah, and this is decent. It just looks so bad because the distance between 2 pi and 3 pi is pretty far off from, yeah, I really messed that up. Just in terms of the scaling, everything else is right, the math is right. Okay, so that's graphing sine and cosine. And yeah, it's really just that same procedure over and over and over again for graphing sine and cosine.